All right. So the solution to mission 2 should be posted in Canvas today. I think I set it to auto post. If it's not, in a couple hours, let me know. Anyway, I'll begin with a word of prayer.
Oh.
Dearly Father, we thank you for this day. I thank you for these students. I just ask you to just bless our time. Help us to just finish what we need to review for test 2, and just to encourage the students if they're struggling, just to continue to persevere and just do their best each day, Lord, for your glory. In your name I pray, Lord Jesus. Amen.
Amen.
All right. Let's get into it. So, go away. All right. Actually, let me just warn you, I probably don't have time to fix this today, and I'll probably just forget to fix it, honestly. Going from here to here, that's not correct. Okay, because, I mean, what's boxed up here, that's fine. That's not a wrong answer, because 3 minus a half is 6 halves minus 1 half, which is 5 halves, right? But when I put that over here, I have to multiply by 3 over 3 to get a sixth there, and 3 times 5 is not 3, it's 15. So that's supposed to be 5x plus 15 over 6 if you write it like that. Right, so sorry.
I got it.
You got it, Michael. That's right. So just to warn you, there's a mistake in the key right there, okay? Any other questions? I'll just open the floor. Anybody? No? Yeah.
About the problem?
Yeah. What was your question?
Oh, I was just going to ask, are you taking specific questions?
Yeah. Just anything in particular that you want to look at?
Actually, can we start off by reviewing long division?
Reviewing long division? Sure.
Oh.
Now, do you want to look at the ones? Let's look at the ones in the mission here. Yeah, Michael?
I'll need your help to figure out problem number 40.
Problem number 40?
Yes.
All right, we'll come back to that in a second, Michael. As soon as I find a marker here. So, long division, let me just make one up. Suppose we're dividing 5x to the 4th power plus 3x squared minus x plus 10. All right? Suppose we want to divide something into that. Let's say, I don't know, x squared plus 3. That's a little bit different than most of the examples we've done in here. So see if you can work that out while I'm adjusting my camera here. You guys enjoying the rain? See, hopefully. All right. So we start out with a 5, x squared. So 5x squared times this gives me what? 5x to the 4th, and then plus 15x squared. And then I subtract, right? What's that give me? Minus 12x squared minus x plus 10. And then what do I want? 5x squared, what? Minus 12, all right. And so I get minus 12x squared minus 36. Notice that I want to make sure I don't subtract that from the x because that wouldn't be appropriate. And that gives me minus x plus 46, and I think that's it. That's the remainder here. Once you get to a term which has smaller degree than your dividing polynomial, then you're done. So what's this all mean? This means that 5x to the 4th plus 3x squared minus x plus 10 divided by x squared plus 3 is equal to 5x squared minus 12
Time.
plus 40, let's say 46 minus x divided by x squared plus 3. So what does this mean? One thing it means is that x squared plus 3 is not a factor. Not a factor of my quartic here. Does that help? Is there a particular thing you wanted to look at? Or?
Oh, you've got help, Mike. Thank you.
Okay.
Related
Yeah.
to that long division one, could you do one similar to the mathematician one where it describes plugging a function into another function for long division?
Which one?
I don't remember exactly what number. There was one similar to that.
You
I want to
mean
say it was in the late 60s.
problem 62? Yeah, we can look at this one.
All right.
I have not forgotten your problem, Michael. We'll go back to it.
So just prepare myself.
Okay. So this one here it was not just a long division, right? It's a long division plus a little bit of a sneaky calculation, right? So here, part A, I said use long division to divide. This laser it comes and goes. It only works about 20% of the time at the moment. I don't know what's up. The batteries are fine. Come on.
There
So-
we go.
Yep. So I divide by x squared minus 6x plus 10. And okay, so I get x squared. That brings this down. Those all cancel. And then I've got a 4x squared minus 21x plus 35. So I add 4, and that gives me a multiple. So this long division is super easy, right? Just 2 steps. And then we're to the remainder. And okay, great. Well, what does that mean? That means that f of x is x squared minus 6x plus 10 times x squared plus 4 plus. So you notice there's 2 different ways to look at the long division answer. The one is like I have here, but just to go back to my made up example here, see, we could also write this as 5x to the 4th plus 3x squared minus x plus 10 is equal to 5x squared minus 12 times x squared plus 3 plus the remainder. So like these are 2 equivalent ways of writing the answer to the long division. And so it kind of depends what you're after, right? But of course the way I just wrote in purple is convenient for problem 62 because well, part B really is where it's convenient for. Exactly. So when I look at this, right, I can complete the square on that if you like. And that's really x minus 3 squared plus 1, right? So what happens with this when I plug in 3 plus I into that one? Well, if I plug 3 plus I into this gives me I, and that gives me I squared plus 1, which is 0. This just becomes 0 when I plug in 3 plus I. So all that you're left with is that term over there. So you get 3 times 3 plus I minus 5 is 4 plus 3I.
Cool.
Yeah, Michael?
Why is this 0 again?
Because of what I represents as a term.
I remember.
When you square I, it'll cancel out with the plus.
Why-
one, that just becomes
So
zero.
why is this term, come on, why does that term work out?
To be 0, yeah, that's the term.
Why does this term work out to 0? Because when we plug in 3 plus I,
3 plus I.
we get 3 plus I minus 3, which is I.
3 plus
That's I squared. Then I squared plus 1 is minus 1 plus 1, which is 0.
0.
And I don't even care.
I squared.
I don't, whatever's over here, I don't really care. I already know that this is 0.
Exactly. it's
So all that's left is what happens when I put 3 plus I over here.
Yep.
4 plus 3I.
Yeah. So as I say over here, this g of x equal to that, g of 3 plus I is 0. So, yeah. Okay, so let's go back to number 40 Michael asked about a second ago. That's a good one to review.
Yep.
So number 40 is a pretty typical rational inequality, right? We're trying to solve this rational function greater than equal to 0. Seems like every time I have to unscrew and screw it back. I don't know what's going on. Look, oh, there it goes again. Yeah, I think you're right. The question is, what can I do about that? Anyway, so we try to factor things, but the good news is that the top cannot be factored over the reals. That's good news.
Complete the square.
Yeah, complete the square. Why is that good news? Well, that's good news because that means there's no critical numbers, which means the analysis is less complicated, right? That's nice. So the only critical numbers are actually 6 and 7, which come from factoring the denominator. So I make my number line over here with my critical numbers, 6 and 7, and I plug in some points, like plug in 10, you'll see that you get a positive number here. And then because the multiplicity of x minus 7 is 1, we flip from plus to minus. And then the multiplicity of 6 is 1, so we flip from minus to plus. And then I'm trying to solve greater than or equal to 0, so I look for where the pluses are for my solution, right?
So 6 is excluded.
Yes, 6 is excluded.
And 7 is excluded.
7
This
is
the denominator.
exactly, since it's coming from the denominator factors where we'd have division by 0 if we were to include them, which we do not want to do. Let's look at a more complicated rational one, because sometimes they're not nice like this, right? Do you remember we had some other problems that weren't so nice? These are all kind of nice, except for 37. 37 is less nice. Why is 37 less nice? Because it's not already factored for you at the start, right? It tempts you to just do what? What are you tempted to do here? You're tempted to just take that and multiply by what? One is tempted to multiply
The denominator.
by x plus 3. But the reason you don't want to do that is because x plus 3 could be positive and it could be negative. So once you multiply by x plus 3, you have just started your own choose your own adventure novel, mathematically speaking, and you have two cases you have to separately pursue. We don't want to do that. We would like to just have one plot line. I'm going to buy a new laser, I'll tell you that right now. The trouble is I buy them from China, so... But I'd say, so next semester in my college algebra you'll see a new laser, but that's not true because I'm not teaching college algebra next semester. So you'll have to come to calculus. But then you probably need to figure out pre-calculus somehow over Christmas break, which would be tricky, right? I do have one student doing that though. Why? Because that student needs calculus 1, and actually that student needs pre-calculus, but the advisor put her in here. Why? Because that's what they do. Anyway, I'm sure there's reasons, but what you want to do is put that into one fraction and compare it to 0. That's what you want to do. So I bring the 2 to the other side and then make, oh, come on, common denominator by multiplying by x plus 3 over x plus 3 like that. Then collect terms. I get minus x minus 17. Notice that this is 0 when x is equal to minus 17, right? That might trip you up, but watch out for that. If there's two minuses, it makes the logic work a little different. So I want minus 17 there and a minus 3 down there. So those are my critical numbers.
So, if you multiply this on the top is really positive 17, then you switch it to negative 17.
Yeah, I suppose the other way we could think about it is just to factor out a minus, right? You could look at that as, minus x plus 17 over x plus 3 less than or equal to 0. I mean, you could look at it like that if you wanted.
So it's still positive 17.
Well, the thing is, in order to make that factor 0, right, you need a negative 17. That's why the critical number is negative 17.
Oh.
Yeah. Anyway, any questions about this one? Yeah.
For the final part, I still don't get why, do you switch out the negative 17 or it stays there because of the negative x?
Well, it stays there because that's what's in the number line, and so the number line tells us what intervals we put over here. So because there's a minus 17 here, that means there's going to be a minus 17 over here. Because there's a minus 3 here, minus 3 is going to be part of the story over here. Now minus 17 is included because it makes the numerator 0, whereas minus 3 is excluded because it would give us division by 0.
So negative 17 minus 17 is 0.
Right, because double negative makes it positive.
Right. Right.
Okay, I get it.
All right. Excuse me. Let's go on and so this one's kind of a similar story, right? 41, you really need to move everything to one side, and then fine. I will use a more basic technology.
You get like a really long pointer.
Oh,
That is creativity.
he did make me scared.
Well, I was imagining like a cheeky little scale.
So we put them on the same side, make a common denominator, factor. This time, the numerator's not a prime. It's actually factorable, which gives us not 1, not 2, not 3, but 4 critical numbers. We put all 4 of those critical numbers on our number line, and then we plug in points. Like a very positive point gives you plus, 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 which is positive. And then each one of these factors has multiplicity 1, which means we flip signs every time. So plus to minus to plus to minus to plus. And then since I'm solving greater than or equal to 0, I look for wherever I have pluses, namely to the far left, right in the middle, and to the far right. So, yeah. Let's see here. Oh. So you guys going to get problem 42 if I put one like this on test 2? You're going to get it?
Oh, of course.
Of course, I see. I see a combination of no and thumbs up. It's nothing. There's no like maybe. No one's like maybe. Everyone's either like yes, I'm going to get it, or like no, there's no way. There's,
Don't do it.
don't do it.
I like solving for it.
How about I make 2 versions of the test, and one version I put it on, and the other I don't. But then I turn out the test randomly. So it's like.
They'd have to be worth equal points.
They'd have to be worth equal points. No,
That was substitute equally.
I'm just joking. I will try to put all of the same kind of problems on both tests. All right, so this right here is the other kind of, it's been a while, but we have solved these problems, remember? Radical. So we isolate the radical, square it, solve the resulting whatever kind of equation we come up against, and then at the end of it, we check our solutions. Some of them work, some of them don't. The ones that don't work are so-called extraneous solutions. So we exclude them from the solution. Yep.
Or one method I did try is to use trial and error to see which number fits in perfectly.
Oh yeah, yeah. That's.
I mean, yeah, I said that back because it only goes up to 10. So
You're like I can just guess your solutions because you're only going to put answers that are between 1 and 10. That's usually true, but what if it wasn't? What if the answer was 42 and you didn't?
That is an awesome reason. What if it wasn't
What's
a
that?
whole number? If it wasn't a whole number, that would be genius.
You're like, well, fine. I'm going to check the numbers between 1 and 10, and I'll also check 42. I'm wise to your game. Well, then I might make the answer like 23. That's also an interesting number. I don't know.
You don't know the
There's
answer.
lots of interesting numbers. How about this? Instead of trying to guess the answer, work it out. Yes. So here we've got 2 radicals, which means we have to isolate pick one of them, isolate it, square it. Remember, when you square it, you actually have to multiply it out. You have to FOIL it out. You don't just write down just this term and that term. There's also a middle term, which comes from multiplying it out. We have to deal with that. And then you isolate the radical again. square it again, and that gives us a solution, maybe. Check if it works or not. If it works, yay, solution. If not, well, there's not a solution. So as a general rule of order, if you have square roots, what you're going to end up doing is squaring it to get rid of the square root, right? However, we also had cube roots. How do we get rid of cube roots? We cube it.
Cube it on both sides.
That's right, cube it on both sides. And when I do that, I get this cubic equation. If you have a cubic equation to solve on the test, there should be something nice about it in terms of like its factoring. And so notice this one's kind of nice because while it is technically cubic, not really, because you can factor the x out, right? And then you're back to a quadratic, and we can solve any quadratic because we know completing the square, right? Or in this case, factor in. So I factor and I get these three solutions. The good news about the cube function is when you cube the equation, you're not losing solutions, so you don't have to check the extraneous thing for the cubing. For the cube, whatever solutions you get, they're going to be solutions because you're not changing the solution set when you cube an equation. Yeah, when you square the equation, you're erasing minuses. So that's why you're getting new solutions possibly. You could be gaining solutions when you square an equation. Now this one here, we worked something a lot like this last class, right? So I don't want to, yeah, exactly. So
why is this negative?
well, because it's in the denominator.
Oh.
So, oh, wait a minite. Hey,
Yeah, that's not
I was
right.
going
I
to say,
thought
that
this was
answer does not
positive.
seem
dude.
I don't see
Whoever wrote this solution is an idiot. Oh, wait.
Hey, don't cut
That's me. Man,
I don't think
well,
the power rating shouldn't be negative. I don't think.
That just means you have to rewrite it.
I'm going to have to go tell my department chair I did this, and I won't be able to teach this course again. It's like,
you
just
should
too.
get fired. Everybody thinks he's
He's not going to get fired. He's simply just not allowed to teach a class.
Just not allowed to teach you. So the solution is this supposed to be 2/3, not minus 2/3, right? No minus, which then puts no minus here, no minus, no minus. Ah!
In the class example we had, it was like a 7,
Yeah.
and we left it in terms of pi.
Good night.
Power.
Yeah, I think you should also rewrite it.
All right, so x over the cube root of x, I'll fix it here, is equal to x to the 2/3. That is given to be equal to pi. So that implies that x to the 2/3 to the 3/2 is equal to pi to the 3/2. Voila, x is equal to pi to the 3/2. That was the actual answer. My apologies, guys. Again, I don't think I have time to fix this solution before I leave, so this is your correction.
You just like put a tiny white piece of paper on the board.
Yeah, just like, you get white out of it.
So as a general point of order, in case we are missing other things, and as you're working through the solutions and studying this weekend, perhaps, I can dream, right? And no, you're studying. What am I talking about? Of course you'd be studying. There's nothing else to do in this world except college algebra. Right?
We all have a Bible. Like,
Maybe next semester you'll find friends and take other classes, but this semester you're just taking my class, so you're just studying this. I know that.
And wouldn't it be nice if it's set parts?
But my point, what I was trying to say, is that if you find other errors, if you want to know if you're not crazy and if I've made another mistake by accident, obviously, email me. I will look at it and tell you, okay? And then I would probably make an announcement to the class for these other things. Hopefully I'll be able to remember these. See, the other section is going to benefit from your suffering here, because hopefully I already know all the errors. Another one you guys want to look at, let's look at the
48.
48. Well, I guess it's there, so.
Yes, please.
wait, if you did it right or not?
Ah,
How does the investing of one make you not
I'm just joking. That's the funny thing is the one thing that like never gets people fired from jobs is like incompetence. Like actually not being able to solve problems. Being rude to a student, that'll get you fired. But like actually not knowing the material of your subject, you could do that for decades and be fine at a lot of places. Yeah.
You're teaching it wrong, but you're nice.
What's
so it's
that?
fine.
Well, the thing is, if you're nice to students and you don't like do bad things to them, you can go a long ways. What's that?
Yeah.
Right, exactly.
Report them, it's so good.
Because also, how if the students don't know the material either, how will they know that you're wrong?
And they just go up to the upper levels and just
Gaslighting.
Okay, what are we looking at for this example?
You think doctors are critical thinkers? Oh, that's funny.
I can't wait for the next generation of ChatGPT doctors. It's gonna be awesome.
Let's talk about doctors, by all means. Okay, let's talk about math. Fine. I will resist the urge to remind you about like doctors in the pandemic or anything like that. But anyway, y minus 2 times y minus 1 equal to 0 here. Michael, so this one, I made a substitution because it's kind of tricky, but if I've got a 1 over x and I've got a 1 over the square root of x, then the way to think about it is like that is really 1 over the square root of x squared. So if I think about y being 1 over square root of x, that's like a y squared. So then with that substitution, it's a quadratic which I can solve. So this is a little sneaky, this problem.
Will the problem like this be on the test?
Sure, why not?
Why would you say that?
If it's in the homework, it's a potential, if it's in the mission, it's a potential test question. Yeah.
Yes, it is.
I'm not I am not promising it's on the test, but it could be.
Like the test is done, guys. He's just.
All right, so some quick reminders. We know how to graph things, right? So
Yes, we do.
this is like the square root of x. You shift it right 3 and then reflect it over the, shift it. Wait a minute.
Would it be the opposite way?
No, it's fine. It's fine.
No, yes.
It's okay. Without the minus in there, it would go
Yeah, that's what I was doing that too.
like that. So I think it's fine. You want me to look at 67? Okay. So as I was saying to you guys, I think a better format for like testing the graphing is just to give you like, choices and make you do the ABCD thing. That's usually the most interesting way to test graphing for me, because actually watching you graph functions is like, it's just bad for both of us. So
Where did this come from?
it would be good to review these to make sure you know the basic graphs, right? Absolute value, don't forget about it. Case-wise defined functions are interesting. Let's see here.
So, for problem number 50, I got them wrong.
That's okay.
That's okay.
Humans are not perfect, believe it or not.
Even Professor
That's right. So we should, before I get to the 67, let's not forget, how do we decide whether something's a function or not? If we have a vertical line, if we have a graph, we can look at the vertical line test. So like this one is a circle centered at 0, 1 with radius 2, so it fails the vertical line test, right? But the instructions here said to solve for y as a function of x, so how do you do that? Well, isolate y. I isolated y minus 1 squared by subtracting x squared to the other side, and then by the square root property, I get y minus 1 is plus or minus the square root of 4 minus x squared. And then, so I didn't get one solution, right? I got 2 solutions for y, which shows me that it's not a function. All right. And in contrast, part B, I took the cube root. I didn't get the plus minus property because it's a cube root, not a square root. And so we got a function, just a single function of x. And similarly for part C, we solve for y there. It's a little bit more troublesome, but we can solve for y. We cross multiply, bring all the terms with y to one side, all the terms with x to the other side, and solve for y. There it is.
Excuse me,
Yeah.
is B correct? Because it doesn't look like it.
Well, you had a cube there, so you need to take the cube root, Michael. That's what it was. Cube root. Cube root.
Oh, cube root.
Cube root, because it was a cube. All right. Now, I said anything could be on the test. That's not entirely accurate, right? Because, well, not in the direct sense anyway, because for these, you had to use Desmos to like find the picture, right? And I don't expect you to use Desmos. There's no Desmos on the test. So if I was to give one of these, I would have to give I'd have to give the graph for you in this case. But
That was fun though.
it is, yeah, once you,
Continue to watch the graph.
it is interesting, like all of the different shapes you can get from different equations. The possibilities are really endless.
Drawing it up.
It's fun to try to find the equation that spells your name, you know?
When I did pre-calc in high school,
Uh-huh.
our teacher, she made us like try to draw
Uh-huh.
a rocket ship using
Terrible.
Desmos and equations.
I'd love to
Very
see
nice.
maybe like an ultra detailed drawing with like 20 lines.
So, don't forget, for domain of function, there's basically two things you're worrying about. Namely, division by 0. Never a good idea. Unless you're trying to kill the function, and in that case, it's an effective method. But setting aside assassination, no dividing by 0. And also, we want the square root to be non-negative. The input to the square root should be non-negative. So I need 9 minus x squared to be greater than or equal to 0. That takes us back to the kind of inequality we solved in test 1, right? This nonlinear inequality. And there's what it is. I think the function operations, most people are going to get that right. You know it? You like these? Ask about these? Okay. Yeah. Let's see here. 57 and 58. These are, in some sense, throwbacks to test 1. You know, I don't know where these fit exactly, but we do want you to learn how to solve just simple algebraic equations with variables in them, because one of the reasons this class is here for you is that it's a prerequisite for Physics 201, where you will have to do this kind of algebra. All right? So anyway, I'll let you guys look at the rest of the solution here. Let me skip over...
67.
Oh, 67?
Just looking at it, like, we don't have to go.
Let me instead... yeah, you don't care. That's cool.
Yeah, I was just
Let-
mentioning,
let-
'cause I had to draw.
So I would encourage you guys to also look at whatchamacallit there, the quizzes that we've had since the last test, right? Which were those? Quiz, what?
4, 5?
4, 5, 6, 7, something like that.
It's coming up.
Yeah.
So
7, 6, 5, and 4.
I will eventually find it.
I want to say it's probably like 5 to 7. something like that.
Here we go. Here's test 2 from,
Last year.
yeah, this is not the most recent, like I had a,
Oh, this is
anyway, this is a,
The same stuff.
yeah, it should be familiar. I think it's relevant, so let's,
1.
this is, well, test, okay, so the confusion is that, let me see if I can just find the right test.
Was it like units were blended differently, so material test so
The thing is, I changed the structure of the course in 2023, so if we can find a spring 23 test, that'll be more relevant.
I've seen some
Of course, of course.
You're killing me, Michael.
I was looking at the old sources because I wanted to find like the lyrics. So I was trying to think.
Come on. Oh, wait. Oh, there it is. All right. So here's test 2 from spring 23. So like, you know, here's...
You got some graphs. That's what the graphs look like. The best one.
This won't,
yeah.
it won't fail me. Volcano, volcano. Upside down square root, that one. This is a cubic, it's that one. Absolute value, that one. Oh yeah, I almost forgot about that. We did do simplifying rational expressions at the start of all this, right after test 1, right? Remember that? So these kind of things could be on there. Yeah, yep.
Oh, are these questions going to be on there?
They could be. That's the start of mission 2, I think, right? Like first problem on mission 2 is these kind of things. So here's an inequality problem. You have a question or?
Oh, yeah, I was just going to say, obviously, I understand, obviously, like, it's not going to be these exact same questions, but, like, are these type of questions, are these the type of questions we can expect on the...
Well, yeah, I taught the course in the spring the same way I'm teaching it now, so it wouldn't be surprising if they were similar, yeah. I mean, I used the same missions even with them as with you guys, so. So here's a rational equation, solve it. Oh man, look at that. It made it to the test.
I think that's
See, Holly?
one of the missions, though.
It made it last semester. It doesn't look good. Looks like it's going to be on the test probably.
Sorry for you.
If I'm a creature of habit.
I'm so sorry.
I thought I just saw the word derivative, but no. I asked the other section if I could do calculus. They said no. Would you guys let me?
It depends.
After this test, can we?
Which part? No, which parts of calculus is the question?
These are funny.
This is algebra. So,
The thing is, guys, this really isn't. Algebra is not actually harder than calculus.
This is different.
It's the same, pretty much. I'm talking about 126. 131 is harder.
131.
Oh, okay, this problem here is like a problem I put on your quiz, right?
Yeah.
Yes.
So, in fact, it might be the exact same problem. Yeah.
So
Yeah,
negative 3.
Yeah.
it is.
I was remembering
Th-
the same exact one.
This problem here gets a lot of people wrong. A lot of people got that wrong, this problem right here. A lot of people got this wrong. Because you have to use a graph. So f g of 1, that's f of 1 times g of 1. That's the product of functions. So, and this one was kind of nasty because g of 1 isn't anything nice.
Oh, yucky decimal.
Yeah, I didn't mean to do that. That's kind of a mistake. So anyway, f of g of minus 1. I mean, if that kind of thing happens, you just do your best to approximate, okay?
Your best.
And
What if we're off by a tenth?
f,
Yeah, off by a test, that's so sad.
well, a tenth I'll allow, but 2/10 no. F composed with g of 1 would be well, g of minus 1 is, oh, g is up there, right? So g of minus 1 is 2. So I have f of 2. F of 2 is 2. 2. So I have to think about that. Let's see what else happened in here. I did have you guys graph something. I'm not saying I'm not going to make you graph something. I'm just going to say that there are ways to ask graphing questions without graphing. So here is an actual you have to graph.
Your intercept system.
It's right there.
Yep.
Yeah, and then to save myself from some madness, I gave a simple question of find the horizontal asymptote.
Oh, this is pretty nice.
That one didn't require graphing. Then I said, you know, this is like one of our factoring long division problems. F of 1, f of minus 1, both 0. So we could factor, and then we factor the factor, cofactor thing there.
Who's Pastor Chuck?
Oh, Pastor Chuck's my pastor. He left though.
Oh,
Yeah, we're now looking for a pastor, which is exciting.
We can trust Pastor Chuck.
Yeah, that's right. So this was yet another long division factoring, but this time the complex factor theorem. Yay. Complex factor theorem. Woo-hoo. And let's see here, what else do we got? Oh, yes. Find the polynomial of least degree with the graph below. So you got to look at it. Notice here that we cross at 6, we bounce at 2, we cross at 4. That puts an x plus 6 here, and an x minus 4 over here because of the crossing.
Well, half.
But we bounce at minus 2, so that's why I have x plus 2 squared there. And then a is whatever I need it to be in order to get my f of 0 to be minus 48. Yeah. See, the thing is, you can make the graph cross, bounce, cross like that, and you can make it as big as you want going up or as big as you want going down. It will still bounce and cross at the same places. So depending on what you make a, you can either make the graph like more steep and going up or more steep and going down. Choice of that a sets the scale basically for the graph. And, but anyway.
So,
And then a radical equation. Radical equation. And another radical equation. And that was it. So that, yeah, your test should be similar length and similar content. Yeah.
but,
Yep, yep.
just study hard and I can do fine.
Study. Well, I would say study hard.
Study what?
I would say I think you've already studied hard. What is important is to relax and be rested and not to stress too much.